In this video, we're going to discuss the first part of assignment 1 for quantitative methods in finance. It's all pretty straightforward and none of it should be too complicated. You just have to know how to plug and chug and how to read the formulas. But we're going to go through it in case there's any confusion, and I highly recommend that you practice all of this on your own as well, because this was the only real part of the class that you had to do major hand calculations. So it's definitely worth it to go over. Without any further ado, let us get started. So question 1, please calculate by hand, not with Excel, the following statistics for stocks A and B's prices. Mean, standard deviation, skewness, kurtosis, covariance, and Pearson correlation. Just a disclaimer, we are not going to be doing Pearson correlation because it's pretty tricky to do by hand. That will most likely be given as an Excel output on the test, so I wouldn't worry about that. But let's get started with mean. So I'm not going to actually solve it, I'm just going to talk you through the solutions that he provided for this, just to save a little bit of time. So let's look at the mean for stock A. First, let's look at the formula for arithmetic mean. The mean is equal to the sum of all the numbers divided by the total number of, in this case, stocks. That's just a simple mean, it's not weighted. So as you can see for stock A, these are the prices. He takes 90 plus 87 plus 97 plus 78 plus 60, divides by the total number of stocks, which in this case is 5, and gets 82.4. And he does the same thing for stock B. He divides by the 5 prices that we have, divides by 5, and gets the mean. So I'm going to go ahead and highlight these because we're going to refer back to them later. Oh, okay, it won't let me highlight just an individual thing. Fine, so just keep track of our mean here and our mean here. We're going to need them later. So we did the mean for stock A and B. Let's do the standard deviation for stock A and B now. So you can see on your formula sheet, there's 2 variance formulas. One is when you have the weights in a portfolio, and one is with just the general variance formula. We're probably not going to be using this one, the variance of a portfolio, at all. So you're mostly going to be looking to this. This formula is also going to be used a lot in confidence intervals and other places. So let's do the variance. So the variance is you take the sum of each individual, in this case price, minus the mean and square it. You're going to add all of those up, and then you're going to divide that whole added thing by n minus 1. So let's see how that looks for A. So for A, we have the price, 90, minus the mean, 82.4, and square it. Plus the next one, the price, 87, minus the mean, 82.4, and square it. Blah, 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 blah. You add all of those up, okay? Divide by 4, and you get 203.3, and that's your variance. Now, in order to find your standard deviation, as you should know, you simply square root your variance, and you get your standard deviation. The same thing for B. You take the price, 1,000, minus the average, which is 1,150, and square it. Then you add it to the next one. The price, 1,120, minus the average, 1,150, and square it. And so on and so forth for the rest of the prices. You would add all of those together. Again, divide them by n minus 1, so that's divided by 4. And you're going to get the variance, which you can see is a huge number. And in order to get the standard deviation, you'll simply take the square root to get the standard deviation. Okay, next is skewness. So skewness is this pretty little formula right here. This isn't a y, this is a gamma. It's not as complicated as it looks. This is just the symbol for skewness, this little gamma. So we're trying to find the skewness of, instead of x, let's say a, right? So again, we're going to sum, just like the variance, the individual price minus the average. Now take it to the third power, and instead of dividing by n minus 1, we're just going to divide by n. Once you've done all of that, you're then going to divide by the variance cubed, the standard deviation cubed, and that will give us our skewness. So let's take a look at how that works in reality. So for stock A, we have skewness. You're going to take 90, the price, minus the mean, 82.4, and cube it. Then add to the next one. 87 minus 82.4 and cube it, add it to the next one. As you can see, you're summing, sorry, wrong one, you're summing all of these. Sum, after you subtract and cube each one, you're going to sum it and move on. Once you've done all of these, you're going to divide by n. So that's just this top phrase here. And then once you've done all of that, you're simply going to divide by the standard deviation cubed. So don't forget that s, whenever you see s with a 2 or 3 or 4, we're working with the standard deviation, not with the variance. So you're going to divide all of that by standard deviation cubed, and you get your skewness. Skewness is negative, so it means we're probably looking at a graph that's leaning more to the left. So now next step will be kurtosis. I'm not going to go over skewness of stock B because it's the exact same as skewness of stock A. So now let's do kurtosis for stock A as well. Kurtosis is basically just skewness on steroids. It's the exact same formula, except instead of to the third power, it's to the fourth power. And instead of taking your standard deviation to the third power, you're taking your standard deviation to the fourth power. So again, in kurtosis, you're going to take your price, subtract your mean, and take it to the fourth. Take your price, subtract your mean, take it to the fourth. Take your third price, subtract your mean, take it to the fourth. Take your fifth price, blah, blah, blah. Once you've done all of that, you're going to divide by n, just like in the formula. And once you've done all that, again, you're going to take your standard deviation for A, take it to the fourth power, and divide your entire beginning phrase by that. And you're going to end with a kurtosis of 1.46. Again, in our course, kurtosis of 3 or greater is significant, so this is a pretty normal, a pretty narrow graph. Okay, so far we've gone over kurtosis, we've gone over skewness, we've gone over variance, we've gone over the mean. Next we have the covariance. Okay, so for covariance, all you need is the means, which we have, and the prices, which we have. And it looks complicated, but it's really not. What this formula is basically saying is you're going to take the first price of A, the first price in A, and subtract the mean of A. And then you're going to multiply that result by the first price in B and subtract the mean of B. So you're going to multiply those two numbers together, and then you're going to add them to the next. So then that would be the second price of A minus the mean of A times the second price of B minus the mean of B, and then add that to the chain. So as you can see here, it's 90 minus 82.4. That's the first price in A times, the first price in A minus the mean in A, times the first price in B, 1,000, minus the mean in B, 1,150. Okay, you're going to go down the line and do that until you've done all the prices. As you can see, it's pretty long and annoying, but as long as you don't make a simple error, it's very easy. You're going to divide all of that by n minus 1, which is 4, and you get your covariance, just like that. Super easy. Okay, lastly, the correlation. The correlation is very easy once you found your covariance. You're just going to plug your covariance in the top and then divide by the standard deviation of the first one times the standard deviation of the second one. So our standard deviation of the first one is 14.26. Our standard deviation of the second one is 133.04. And the kurtosis, the covariance is the same for both because it's covariance, it's both of them together. So all you do is you take the covariance, divide by the standard deviation of the first times the standard deviation of the second, and you get your correlation. It's easy as that.